Hey there, seventh grade. How we doing? We are going to be talking about some of the tools we look. Hope you're happy. Anyway, I will stop with the dad jokes. Never. They're gonna come a lot. Sorry about that. Anyway, what we are going to be discussing today, guys, are using globes and maps. These are two of our most popular things we like to do in geography. As you can see by the globe behind me. Ooh, isn't that neat? It's the Earth. Anyway, we're going to talk a little bit about how to use globes and maps today in today's lesson. So if you are ready, let's go. All right. So when we talk about globes and maps, what we're discussing here, let me put this up here so we can see everything really well. When we talk about discussing globes and maps, it's really about one of the geographer's best things is one of the most accurate tools that we can actually use as geographers. So it's one of those things that we will definitely be using throughout the year and probably throughout your life. It's just one of those things. Let's move forward. To locate places on Earth, one of the things that we use are a grid system. This is this line that you're looking at. It's one of the reasons why I have the background looking like this. This is what a lot of people call the grid system. It was one of your vocabulary words this week. And these lines form the equator, they form the prime meridian, and they kind of go around the Earth like a belt. And this is kind of how we determine absolute location. So if we're looking for your exact place on Earth and whatnot, you're going to be using these grid systems. It's also a way to divide the Earth up into spheres. You've probably heard the word hemispheres. So there's the northern hemisphere, the southern hemisphere, eastern hemisphere, and western hemisphere. So, north, south, east, west. But, it's just basically dividing it into, hey, if we say northern hemisphere, you and I live in the northern hemisphere. We know we're talking about from the equator north. And if we're talking about the southern hemisphere, obviously the equator south. We also live in the western hemisphere. That's separated by the prime meridian. So that actually goes through Greenwich, England. And so since we're west of Greenwich, England, we're considered Western Hemisphere. And then if you're east, they consider that Eastern Hemisphere. All right. Everything north of the equator, like I said, is your Northern Hemisphere. Everything south, a lot of this is just common sense. All right. So everything south of the equator is your Southern Hemisphere. And the other imaginary line goes from north to south. Okay. This goes from pole to pole. What that does is it divides us the other way, and that is our prime meridian. Your prime meridian, really important to know. Like I said, the only difference is between the equator, besides it being like this, your prime meridian not just goes north and south, but it's also not necessarily through the center of the Earth. It goes through that Greenwich Village over there in England. So here is a little chart to kind of show you how we divvy it up. Like I said, we live up here. Here's North America, the Northern Hemisphere. And then you look at the prime meridian, and it goes through Greenwich, England, which is right up there in that little island. And like I said, since we live west of that, we live Western Hemisphere. And then everything east, India, China, parts of Russia, Saudi Arabia, parts of Africa, Australia, that's all considered Eastern Hemisphere. So fun stuff. These lines of latitude, all right, these are parallels. All right, we're going to use the word parallel or horizontal. This is what the equator is made up of, and it measures the Earth. Now, here's where it gets interesting. Because here's your equator, anything north or above it is a northern number. Notice that. It says 15 degrees north. Most maps will break it down. If you're looking at, by degrees, just depending on the projection you're looking at, we'll get into map projections and stuff later this week. But when you look at projections and whatnot, it just kind of depends on which degrees you're looking at. The thing is anything above the equator, that's north. All right, we understand that's to be north. Anything below the equator, that is south. All right, the equator reaches 0 up here. That's 90 degrees north. And in the equator itself is the 0. So you go 0 up to 90, and then again 0 to 90. We know where you're located because of either it's north or south of the equator. Okay. Lines of longitude are called meridians, all right? And these are kind of your vertical lines, okay? And what this does is they go up and down. Now, again, you see that little line right there? That where the arrow is pointing, that's Greenwich Village. Okay, that's Greenwich, England. And the reason they did this is when they were developing this, the National Geographic Society was actually based in Great Britain. This was where they did it. So if you're ever wondering why the prime meridian goes through England, that's why. It was back in the 1800s. So those lines, though, go from pole to pole. And so because here there's the North Pole and here's the South Pole, your prime meridian here becomes 0. And that's 0 degrees going through England and here, these other parts of the world, Africa, Spain, France, those areas. All right. But the difference is if you go, it's just kind of like the equator. You go here, if you go farther west, everything becomes 15 degrees west, 30 degrees west. And if you go east, it goes up to that. The difference is, though, the equator goes up to 90 degrees. The prime meridian goes up to 180 degrees. And that's because the world is a sphere. It's a ball. All right. And because it's round, for those of you skateboarders, you guys know if you guys do a kickflip and then a 360 on a half pipe, you've completely turned all the way around. Whereas prime meridian doesn't go all the way around. There is no 360. It goes up to 180. So for example, if you're looking at my little picture box, that's me staring at you 180 degrees, which means I'm completely turned away from you. I turn another 180 degrees, now I'm looking at you. Fun stuff. Grid system, though, is formed by lines of latitude and longitude, and that makes it possible to find absolute location. Like I said, the grid system, that's what these are. That helps you find the exact location of everything on Earth, and that's what the geographers have put in so we can find stuff on your GPS at all times. So whether it's your phone, whether it's something in your car, whether it's a satellite beam, we use GPS to locate that. Only one place can be found at the point where a specific line of latitude crosses a specific line of longitude, and that's why it makes it, the grid system. That's why it makes it your absolute location. There are points in between our degrees. Those are known as minutes. For our 7th grade class, I'm just going to keep it at degrees. We'll get into minutes further into the year just because that's a little bit more of an advanced concept when we're getting into this. We use degrees. I have this here like this. That's your degree. And then we use the minutes. We use that. Those are the points between the degrees. People can pinpoint any precise spot on a line of latitude when it creates one line of longitude. Again, you find your absolute location. In this picture, it gives you a really good idea of the grid system. Here's your equator, 0 degrees. You could literally say, hey, what's 0 degrees by 0 degrees? Well, 0 degrees by 0 degrees can be located, over there, on the other side of this globe. But if I say, hey, what's 0 degrees by 105 degrees east? You follow that line up, it connects, and I know I'm somewhere by Indonesia. Okay, that's what this landform is. So again, exact positions, exact positions. If you go 30 degrees north by 105 degrees, you go to the 105 degrees, match it up with that. Now we're somewhere in China. If I'm going to go 135 degrees east by 30 degrees south, now I know I'm over here in Australia. That's how the grid system works. Most accurate way to depict Earth is using a globe. One of the reasons why we have them. Problem is, these don't exactly fit in your pocket, do they? So they're a little bit harder to use, but it is the most accurate representation of how we have the Earth. All right, your shapes, your land masses, your bodies of water, globes accurately represent the Earth for distance and direction. And the reason is, globes are round like the Earth. All right, so when we look at that, because the globe is round, that helps remind you that, the Earth is round. Maps, and you'll hear me say this throughout the year, maps are flat and the world is round, which means, since maps are flat, it leads to what we call projections. And various projections and various maps can display political boundaries, population densities. They're really important, but they're not always the most accurate as far as size or as far as, length, because maps, because they're flat, they have to get stretched out, and that kind of leads to some inaccuracies with some of those map projections. So your most accurate measuring tool for Earth is actually a globe. Maps, however, though, have their limitations. Like I said, If you draw a round thing on a flat surface, it gets really difficult. If you were to try and draw something on an orange and peel that orange, it's not going to look the same. Or if you draw something on a balloon while it's inflated and then you deflate it, it looks a lot different, doesn't it? Same thing with the map and planet Earth. Cartographers or map makers are basically people who use mathematical formulas to try and take and make our maps as accurate as possible. And we're trying to take something round, we're trying to put it on a flat surface. But even with modern technology, we still end up with curves kind of becoming straight, and that distorts the image. So it does kind of throw things off. So some maps are going to look a little weird. Map makers have had this problem for as long as human beings have been around. So like I said, that has been a thing. Now, are we getting better with technology? Absolutely. We have this. One of the big things we use, though, is called the Great Circle or the Great Circle Route. Pilots use this when they're flying airplanes. If you're flying on a plane, you're going to use the Great Circle Route because when you look at it, the world is round and maps are flat. You can draw a line on the equator, and we can show you an example of the Great Circle Route. I'm about to show you a picture of that. So when you travel, great distances, you're going to follow the Great Circle Route. For example, I'll show you this picture. When we have this picture of it, you'll see that if you fly from LA to Tokyo, if you drew that straight on a line, you're going to travel 5,795 miles. But remember, the world's round. So if you actually take that and come from LA and fly upward where the world is a little shorter because it's round, you can come back down and land. And instead of flying 5,800 miles here, now you're flying 5,450 miles. So you're saving roughly 300 miles of travel time. That's hours in a plane ride you're saving. That's mileage, that's gas, that's all sorts of stuff. So pilots use this probably the most more out of anybody else. The idea of the Great Circle Route is an important difference, though, between the globe and a map, because the globe is round. Like I said, it accurately depicts what circles look like. On a flat map, if you looked at this, you see this, you're like, well, that's weird. Or if you looked at this, you're like, oh, there's the Great Circle Route. Suddenly the Great Circle Route looks straight, and the true direction route looks bent. Something to think about, all right? So when you look at a flat map, though, remember, you're really looking at a distorted image most times. So a globe is actually your best thing. Hopefully that will help you today. Don't forget, guys, today we are using an Ed puzzle for our lesson. So I will have questions stopping throughout the video. Don't forget also, your definition should have been turned in last night. I will have the terms posted this morning. They will be taken down though tomorrow, and your quiz will be posted at 10 a.m. So you can work on your quiz then. All right, we will Zoom tomorrow, and I will catch you then. Later, Gators. Bye-bye.